You evaluate the integral using polar coordinates. So already, what are the polar coordinates? We have seen in last lecture that x is equal to r cos theta and y is equal to r sin theta are called polar coordinates. Okay, and in this case, j is r, Jacobian is r. That is dava xy, dava r theta is r, and these are called polar coordinates. Already these problems are observed in last lecture that if there is a x square plus y square like factor, then substitute x as r cos theta and y as r sin theta, polar coordinate. So here is x square plus y square means substitute x as r cos theta, y as r sin theta. Similarly, evaluate these problems using polar coordinates. So first problem, that minus a to n root a square minus x square. So this is limit on y. Y is minus root a square minus x square, and y is root a square minus x square. So if we simplify this, then we have as if we taking square of both sides, this or this, then we have y square is equal to a square minus x square, that is x square plus y square is equal to a square, that is circle is x square plus y square with center 0 0 and radius a. So we have to use the polar coordinate. So and x is minus a and x is plus a. Okay, so x substitute x as r cos theta and y as r sin theta in this integrand. So that is dy dx, or dx dy replaced by what? Replaced by mod j, that is r d theta dr d theta. Okay, that dx dy replaced by r, and x is replaced by r cos theta and y is r replaced by r sin theta. So if we write here x as r cos theta, then what we have, r means here radius is a. So r runs from 0 to a because radius is a, and theta runs from 0 to 2 pi. In order to cover this region, we have to move theta from this point to this point, that is 360 degree. And so the roots are what? The given integration is 0 to 2 pi is the limit on theta, 0 to a is the limit on r, and r dr d theta. Okay, r dr d theta. So limit of r and limit of theta. From figure we observe the limit of r and limit of theta. So this integration converted to integration, double integration 0 to 2 pi, 0 to a, and this dy dx or dx dy is replaced by r dr d theta because of that theorem. And then its integration with respect to r is r square by 2, 0 to a, then value at the upper limit minus value at the lower limit, and then integration of 1 is with respect to theta is theta 2 pi minus 0, and so 2 to get cancelled, so pi a square is the integration, this pi a square. Then next problem is this 0 to 2, 0 to, this is limit on y is 0, y is this, y is root 1 minus x minus 1 bracket square, x is 0 and x is 2, from this x is 0 and x is 2. So if we simplify this, that is squaring both sides, we have x minus 1 bracket square plus y square is equal to 1. That is x minus 1 bracket square, y minus 0 bracket square is equal to 1. That is, this is the equation in the form x minus a bracket square plus y minus b bracket square is equal to 0. That is 1 0 is its center. Radius. This is the equation of circle, and with center 1 0 as its center. 1 0 is center, and radius is 1. Radius is 1. So draw a circle having center 1 0 and the radius is, and x is equal to 0 means the y-axis, x is equal to 2, x is equal to 2 is the line parallel to y-axis passing through this point 2 0 point, x is equal to 2, and y is equal to 0 means x-axis. So this is the shaded portion, y is equal to 0 indicates that the portion is circle is above the x-axis, above the x-axis. This is the shaded portion, is the portion of integration, region of integration. So the region bounded by these 4 curves are this, that y is equal to 0, y is equal to this, x is equal to 0, and x is equal to this. And then substitute x as r cos theta and y as r sin theta, therefore dx dy is r dr d theta. Okay, and then r runs from, radius runs from 0 to 1, 0 to 1, and theta runs from now 0 to pi by 2. Theta runs from, r runs from 0 to 1 radius. R runs from, leaves r is equal to 2 cos theta, and theta runs from 0 to pi by 2. Because of this, equation of circle is this x minus 1 bracket square plus y square is equal to 1. So if r is r here, we consider the ray from origin. Okay, this ray from origin, and to cover it enters the region where r is 0, and leave the region where r is 2 cos theta. This ray enters the region where r is 0, that is radius is 0, and leave the region where r is 2 cos theta. To cover the entire region, rotate the ray theta from 0 to pi by 2. 0 to, in order to cover the region, we have to move the region, this ray from this point, that is x-axis, to y-axis. That is to cover the area, we have to move this region from 0 to pi by 2 in angle 0 to pi by 2. So theta is 0 to pi by 2, and r runs from 0 to 2 cos theta, and therefore this region, so this ray, along this ray, r is 0 and r is 2 cos theta. So lower limit and upper limit, and then substitute x and y as r cos theta and y r sin theta. Okay, we have this, and then integration with respect to theta now first. Theta, integrating theta with respect to theta first. Is cos theta, integration is sin theta, cos theta, integration sin theta minus cos theta, then value at the upper limit and value at the lower limit. This is the integration with respect to this 0 to 2 cos theta is limit on r. So integrate with respect to r first. So integration is what? 1 by r. Integration is log r with respect to r. Okay. There is no r, because this r into r is r square divided by r square is 1. So just cos theta plus sin theta. So integration is with respect to r, means cos theta is constant. So its integration is cos theta into r, and integration of sin theta is sin theta into r. And then we have the, if we substitute r as 2 cos theta, we have 2 cos square theta plus 2 sin theta cos theta, minus if we substitute r as 0, we get a 0 answer for lower limit. And therefore then integration with respect to theta, and with respect to theta is what? 2 sin theta cos theta is sin 2 time sin 2 theta, and sin 2 theta, then substitute as sin 2 theta as, so this is the integration. Cos square theta, integration is substitute cos square theta as 1 minus sin 2 theta divided by 2, and then we have this answer by integrating, and then value at the upper limit minus value at the lower limit, we have this answer. So the third problem is this 0 to 2, 0 to x, that is y is 0, y is x, X is 0, X is 2. So draw that these lines. Y is equal to X, then X is equal to 2 is the line, then X is equal to 2, and Y is equal to, yes, Y is equal to, X is equal to 0 means Y axis, Y is equal to 0 means X axis. Okay, X axis. So this is the region. And then draw arrow. So X is r cos theta, Y is r sin theta, dx dy is this substitute. And then to find limit of r, consider the ray from origin. Consider the ray from origin. So it enters the region R where R is 0 and leaves the region where X is 2. X is 2 means R cos theta is 2, means R is what? 2 by cos theta, 2 sec theta. Similarly here, this R runs from R is 0 at this place, and at this place R is 1. R is 1 uh, at this place. R is 1. X is 1 at this place. X is 1. On this circle, like this. R limit of R enters R is 0 and leave the region where X is 2. Leaves the region where X is 2. At this line, X is 2. Like this, at this on this circle, X is what? X is 2. X is 2. And X is 2 means 2 cos theta. R cos theta is R is 2 cos theta, because X is R cos theta and R is 2. So we have X is R cos theta and R is 2. Radius is 2. Therefore, R is 1, radius is 1. But it is, if you take the ray at this place, then X is 2. X is 2. That is R cos theta is 2. So similarly here, R cos theta is 2, because at this place X is 2, but X is R cos theta. R cos theta is 2, therefore R is 2 sec theta. So to cover the region, rotate the ray from theta from 0 to up to this pi by 4. This is pi by 45 pi by 4. So we have to rotate this ray in order to cover 0 to pi by 4, and therefore the limits are what? So the limits are, this is the given integration is converted to 0 to pi by 4. Theta runs from, R runs from 0 to 2 sec theta, and the integrand converted to this integrand. What is the integrand? This is the y. Y is R sin theta, and dx dy is R. Dx dy is R. dr d theta. Therefore, R square sin theta. Then integration with respect to R first means R cube by 3. R cube by 3. Then upper limit value at the upper limit, that is 2 sec cube theta by 3 sin theta. Sin theta by 1 sec theta, 1 cos theta is 1. So the sec cube theta means 1 by cos cube theta, or sin theta by 1 by cos theta, by divided by cos theta is tan theta, and that is sec cube theta, 8 sec cube theta, 8 by 3, and 8, right, 8 sec cube theta is sec theta into sec square theta, and that sec theta is 1 by cos theta. So we have this, and then sec square theta as a substitute as sec square theta is t, and therefore tan theta is t, and therefore sec square theta d theta is dt, and then its integration is t square by 2, and then value at the upper limit minus value at the lower limit, we have the answer. So these are some problems for homework. Find the area of the region cut from the first quadrant by the curve. So area of the region is integration 0 to pi by 2. First quadrant means 0 to pi by 2. And theta runs from, r runs from 0 to 2 root this, and r drt theta. This is the area. Dx dy is what? Dx dy is r drd theta, mod j drd theta. And the limits are what? 0 to, in the first quadrant, therefore 0 to pi by 2. For first quadrant, when theta is runs from 0 to pi by 2, and this is the area, and solve this, we have this answer. Okay, first integrate with respect to theta, with respect to r, then lower limit, upper limit, lower limit values, and then with respect to theta, we have this answer. So this is the problem for homework. Using polar coordinates, solve this problem. Answers are given. So we will see the more problems of changing of variable in the next lecture.